This is my lab report for Lab 4 bar magnets. So the purpose of this lab was to measure the dependence of the magnetic field on a small bar magnet, and we compared the predicted and observed values for both on-axis and off-axis magnetism using our phone's magnetometers. Preview of the results, we got n equals negative 2.99 and a magnetic dipole moment of 4.613 angstroms. So the main things we used in this lab was the Biot-Savart law, the magnetic field and magnetic dipole equation, and the distance dependence formula. For the procedure, first we oriented our phone's magnetometer so it's perpendicular to the Earth's magnetic field. Then we found the location of the magnetometer through calibration procedure and measured the distance between the magnetometer and bar magnet for both on-axis and off-axis measurements. So this is just a table of our observed results on axis, and then this is a plot of the natural log of bx versus the natural log of r. These are our calculations. As you can see here, we have our values, and then we have our formulas set out, and then we plug in to calculate for the magnetic dipole moment. These are our results for the off-axis measurements, and we did pretty much the same thing with those. For assumptions and error, we assume that the bar magnet acts as a perfect dipole, which could not be true if there's any imperfections on the surface of the magnet, and that magnetic field decreases with distance. Sources of error include electronics in the room creating additional fields, especially like the laptops messed with the magnetometer, and the magnetometer location being imprecise. This is the glow script code, so we just use the magnet function to create the magnet at the certain position, and then we create a function to calculate the field of the dipole given our constants. These are just a bunch of vector statements for each respective location, and then we're calculating like the relative magnitudes of the distances. After that, we plug in for the magnetic field of the dipole, and then we can calculate for the magnetic dipole moment. So we're printing out the B field at 45 degrees at distance d and the magnitude of B as well. This is just a visual, like a picture of the outputs. You can see the vectors at the measured locations from the lab, and the values that we got are also consistent with the values in the lab. For the what if questions, if we hadn't oriented the experiment to compensate for magnetic north, we wouldn't be able to calculate our values because everything is based off of the deflection. Like we already have a basis for what the magnetic field of the Earth is, so when it's oriented based off north, we can calculate based on the changes, but we wouldn't have a basis to measure off of if we didn't orient it in that direction. And if we were to stick two identical magnets together and run the experiment again, the magnitude would increase and direction would be unchanged, but the magnitude wouldn't double because stacking the magnets together doesn't perfectly double the magnitude.